And we're live again. And thank you so much for episode 3 of this continuing podcast on physical AI hosted by Tryfecta Capital. Excited to have our co-founder, Nathan Maroney, here. And we are basically going to have a deep dive into everything mining. So, Nathan, we're going to have mining as one of our pillars of physical AI. Why is it important? Why do we need to even consider mining? And why are we going to spend all this money into mining? Yeah, shoot.
Well, basically, our economies run on technology-rich applications, from computers to smartphones to EV vehicles, even to combustion engines, which have multiples of sensors and, are relayed through computer systems to, technologically controlled. So at the end of the day, we're in a system where the necessary evil is commodities. And if you look at what's required in just a general chip or a circuit board, there's gold, there's silver. I've done lots of little experiments at home just by melting it all down. First of all, you have to extract it off the circuit board, and you can use a homemade solution. Toilet cleaner can do it. Anyway, you get that, and you kind of evaporate it off, and
definitely don't recommend it. Don't do it at home, right?
But anyway, yeah, you can get these hard commodities, and you can actually melt it all down. I've done it, and you need a lot of it. So there's people out there who do that. They normally recycle the circuit boards for these very commodities. There's a business around that. So you need a truckload of silver for ammunitions. You look at missile and defense. Silver's currently the go-to for that, but as the price of silver goes up and the medical applications in silver alone, silver's a biological enhancer. It also is a sterilizer, something you used to use before modern day antibiotics and things like that, as a topical lotion, and even inherent solution within the body. So there's so many use cases for silver, and currently it's underpriced and there's not a lot of it to go around. So this when I've worked in my career, from surveying all the way over to automation and process control, digital twins, oil and gas upstream, I look at things wholly as solutions across different disciplines and resource sectors can be adapted to fit. As a perfect example of that, coming from mining drilling and going into oil and gas drilling, there's a huge technological leap. But the reason is there was more money invested in oil and gas, and the return on investment was worth it. When you look at mining, a lot of it was mum and dad operations, and they're just trying to do things cheaply and cost effectively. The balance sheet doesn't justify the big expenditure. And so they're almost in a bubble where a lot of the technology that was developed in asset classes where there was a lot more funds to go around meant better returns. So there could be more funding for that. So adapting some of these technologies in mining is where you can fully get an appreciation for the expenditure put into it from another perspective, and then brought into your capabilities. Now, I look at mining across the board and go, wow, there's so much we can tackle. There's so many things you can do, but you have to have smart resourcing to be able to do it. With the adoption of AI, you have that smart resourcing, and you have the ability to cost effectively compete against
but that's just one. But that AI so AI is already here. I think the jack's out of the box here. OpenAI, for better or for worse, has opened that lid. Before, we started working on AI years and years ago, and AI was always a thing, but OpenAI has kind of made it consumer grade. Now everyone has access to AI, right? So anybody in any aspect of the organization in a mining company now has access to AI. So that's now built, that's there. I suppose the question right now is, what's next, right? Like, it's going to be the contracts guy in a mining company is going to use AI for contracts. And the surveyor is basically going to be looking at some form of AI to help with filling his reports in. I mean, is that it? Are we going to relegate AI to that level? I think there's a bit of a feeder here, right? Because AI needs materials and minerals, and at the same time, AI is going to drive materials and minerals. Where's that distinction end? Where does the distinction start, for that matter? And as Tryfecta, why are we interested in it?
So look, I was involved in a project that we ended up winning. I led the project, and it was a big bid for a resource-rich copper play in South Australia. And yeah, we ended up winning that job. Now, the whole vision for that was that it was a lights out operation running 24/7. So there had to be renewables, there had to be a lot of technology applications. One of the biggest problems you have with that vision, and they paid a lot of money for that white paper, that document. They gave them that outlined that vision. But the vision's correct, but the execution's very hard. That means you have all these levels and layers within your technology applications, layer 1 or 0, and then 1, 2, 3, 4, 5, all the way up to the executive level. You have OT 3, and then sensors down level 0, and then you have the demilitarized zone between the two of them. But at the end of the day, you have all these disparate technologies. None of them really integrate well with each other. It's all IP protected. But one low piece of hanging fruit is, well, you need a master database, which most of them do through the PLC system or the SCADA system. But inherently controlling all those systems and having intelligence behind it, mechanizing it, that's a human job. This is where AI needs to step in and go, hey, I can make this operation run really sweet, disparate technologies, and they have command structures inbuilt, like you have automated trucks and so forth. You can demand operations, you can save revenue, you can save many, but there's a process in order to step through that. And having that technology application attitude from oil and gas, you bring it into mining. Now, how do you monetize it? How do you get it out there? That's where Tryfecta Capital looks at it and goes, well, we de-risk it by technology applications that we can employ. And that gives us the advantage, key advantage, especially around distressed assets. And as we look today, and like distressed assets are going to be dime a dozen, because there's a lot of remote mines that just run on diesel. So you need to know how to run these operations efficiently. And you can do that through energy control, energy reduction. There's mechanized systems around that, 5 capabilities and so forth, and electrical. But that's just one way of looking at it. But there's also the operational aspect of it. And a lot of it can run remotely, with minimal staff on site. You have sites that are currently running in care and maintenance. Well, that could be your go-to in the future, just a care and maintenance crew. Titto, we've been involved in oil and gas. What was our agenda? At the end of the day, it was to de-man the directional drilling rigs and have the guys remotely controlling it in a distant office in Brisbane. That should be the same attitude you bring to the mining capabilities. At the moment, they're looking at the coal face or the bogger loader or whatever, doing it remotely. I'm talking everyone remotely. I don't even need cleaning staff there. I don't need to feed anyone. I've worked on exploration projects, like the logistics of getting everyone there every 2 weeks. You need a whole team around it.
Rio Tinto has been doing this for 16 or 17 years with their blasting solutions, I think, with that facility outside of Perth Airport. So it's not new to mining, right? Like,
not
so
new,
what do
but
we
the genesis of it all coming together as one, that's new. And that's how oil and gas
the
thinks.
consolidation. Yeah, the consolidation and consumerization. That's going to be the key thing. Yeah. So I suppose, so mining is big capital plays, right? We are looking at a 5 billion AUM. We need way more than that just to start up one mine, right? So I suppose the question really is, where is that capital going to? So you're talking about that intersection between technology and getting these minerals, right? Where is that intersection, right? So the way I look at it, I'm looking at it and saying, and this is kind of the issue we've had with, and so oil and gas is not going to outlive the AI revolution. Oil and gas is still a very critical part of the world around us. And right now, as the Iran war is going on, I think it's evidently clear to everyone that we have not weaned ourselves out of oil and gas. And so while it plays a big part, I don't think it's going to be the future. As someone, with investments in oil and gas, a company that has work in oil and gas, I think everyone's clear that it's not the future. Right? Now, I have a different take on it, and this is the view that the energy industry, right? So what we're doing is it's called the whole energy life cycle. So we're kind of increasing the energy mix, where we have multiple different energy layers that can help us, so meet the demand, right, that the market needs. The same thing for the mining and the minerals, where I look at it and I say, hey, listen, it's not just about this one big mine here. We can actually target smaller pieces, right? Talk to that and tell me about a little bit. So I'm kind of, mining is not my expertise, and you have such a good experience with mining. How is that possible? Like, where do you see that same vision possible where we can access much smaller deposits, much more complex deposits, and bring that into the supply chain? And really, I think it's important for all the listeners to kind of understand where physical AI is going to change. And also, let's respect the fact that we're not at a, you know, ChatGPT event for physical AI yet. That's at least 2 to 3 years away. So we are way behind the curve here, and we're sort of setting up for the curve, right? And so in that worldview, and when we talk about mining, and I think we'll sort of go through all the critical pieces, especially the rare earth metals. Talk to that. How are we going to, do you think that's a valid strategy where we are basically going after harder to get minerals, smaller deposits, which technically they were economically unfeasible maybe 2, 3 years ago? So will physical AI actually open up those smaller blocks?
So, yeah, it's a good question, and it's subjective. I would put it that way in a small take, but just rewind back. Look, I started off in surveying. The surveying technologies were all about, for exploration, better surveys, using gyroscopes. You basically wanted to know where the drill string was and exactly where the hole was. You had to use a gyroscope. Before that, you had cameras, which would give you a good estimate, but you could be off. And if you know your tangents, if you're off by 1 degree at this point, and point B is, another 500 meters away, 1 degree over that amount, you're up for 100 meters or something, So you just have to know where the problem was, and then to fix it, to get your actual grade that you're looking for. Because if you start blasting in areas where there's no grade or commodity, so this was a problem that we had to solve back in the day, and we used gyroscopes to do it, and we had better and better gyroscopes. Gyroscopes inherently had their own technological problems, but at the end of the day, you work through them and try and R&D these issues out. That allowed us to hit, because the complexity of an ore body became longer or deeper and harder to get, but the processing of it was still relatively easy, So if we're talking nickel or copper or gold, or and the grade, it's the grade, but your process is good enough to get that grade out. So okay, we know we can get 1 gram a ton of gold for this mine. The problem became, because you had to dig further and go after smaller grades. I mean, you still got to feed the plant. You still got to have the operators. So the price has to be where it needs to be to go through that big effort to extract it. Prices are favorable now, but there are other economic factors coming into it. So you just need an operation that's going to be efficient. So if you go for something that's a lower grade, maybe you can find a higher grade. It doesn't really matter. If the price of the commodity is there, you develop the resource, you then have a resource that you can obviously sell in the market, or you turn into an operational mine. So, and there's always companies out there looking for that. So it really depends on your target market and what you're looking for. But because I've done geoscience, I've done drilling, I've done disciplines in mineral processing, and gone into automation, and then I look at it holistically, and I see many problems that can be solved everywhere. So there's energy complex problems around, burning diesel as a remote mine, for example. We discussed that before. There might be process requirements for rare earth that need to be met. That's a process issue, not necessarily, because digging it out for rare earth could be a shallow thing. You don't need to dig out much, and it's just a couple of loaders, but you could apply physical AI to those loader operators to actually make them geospatially aware, to do that without, 3 operators. You could now just have one operator overseeing 3 units. These are improvements, and you need to know where you can make those improvements and holistically feed it back into a generalized Genesis AI that can actually orchestrate it all and project manage it for you on the fly. That'd be my go-to as a lights out operation. Who's thinking that way is one question. Who's willing to fund it is another question. But I think what we've managed to do is bring those 2 points together. We're thinking about it. We're willing to fund it. And we can look for partners out there who would allow us to help them, complete their operation efficiencies by deploying it. And there's many ways we can look at funding that because we have access to the capital markets. A lot of people don't have that pillar either. We also have access to other things that are essential for us to drive this forward, such as investment funding around our research in these areas. And I think it's important to showcase some of the expertise like yourself coming from that science background as well, where you've developed it and you formulated this and you deployed it in the real world. I helped you with that on one project. It's not like it's monkey business. It's like, hey, it's this technology that can be adapted, but you have to have the foresight to do it. So that's where I think we're coming to this from a different perspective and looking at it where you can tackle those issues with the right expertise.
No, that makes sense. I mean, in the next episode, we're going to get into all things rare earth, because I think that's going to be an interesting one, but so we're almost out of time for this one as well. And it's been such a productive discussion, but let's get into the home stretch of this episode here. Let's deep dive into the business models. Let's deep dive into what is the business model of the future. Mining, especially, such a huge industry, and it's got so many different layers, and both vertically and horizontally, that's required to kind of complete a mine, get a mine. It's a supply chain problem. It's a logistics problem. It's an engineering problem. So many complex issues around it, and also where we kind of might run out of certain things. We might economically run out of certain materials and minerals. Talk to the business models. What sort of business models do we need to talk about, and what sort of business models do we need to focus on for this future? So we are basically going to see, physical AI is not, it's in its infancy. Jensen Huang and all the big guys over at NVIDIA, they're talking about it now. We see that automation, you had the Ubers and you had, all the other people, Teslas and whatnot, they've worked on automating cars and trucks and all that sort of stuff, which is cool. But when we're talking about sort of automating an entire mine, talk to the business model. What can we expect? And what's the right way for capital to flow into that? And a lot of new founders who are going to be, who are working in the space, what do they need to focus on? What are the challenges? Where's the market? Yeah, I'm keen to hear your thoughts on it.
Well, I was working for a automation company, the world's biggest automation company, standalone. When I was running the business for projects for them, I liked the fact that the first thing that CEOs or directors on a project were thinking about is, what automation platform do we run on? So you're normally called in to be one of the first, except for really long lead items. Maybe it was something in the process that might have been a kiln or something terribly long lead items. But we had these early conversations around, what are you going to do? And you do a lot of feed studies around that and, pricing structures. But it really came down to the fact that directors or managing directors of these companies wanted to know what platform they're going to run their technology on. It became more important than the IT technology, it's well structured IT, but with an OT, it's, got a few big players that have different capabilities and different, styles of approach for depending on what technology you have and what you're looking to do and the process requirements. Having said that, I see the AI of the future, physical AI, being the first thing, and then managing director calls and says what platform we're going to use, because everything else trickles from that, even IT, because it's going to be controlling all your infrastructure and managing it, security threats, everything, reporting, and that's going to be reported up to a
Your
database where humans can have it.
Process economics. How are you going to extract it? What's the return? Is it even worth investing in it? Right?
Yeah, exactly. So if you look at that from a process economics perspective, it's going to be able to enhance everything that you're doing. To put a number on that, there's an efficiency factor around moving large tonnage through a process plant. And that, especially with iron ore, you can improve efficiencies around 1% of throughput. You can have your recovery is better. That's equal to millions of dollars, millions in the bank, just 1%. So what we will plan to demonstrate is that through using a Genesis environment of AI across your whole ecosystem, which will plug into everything relatively easy, you won't have disparate technologies. that's an enhancer, but just by time itself. You reduce engineering just by time itself. You reduce the need for multiple bodies of that engineering, and then operations. Operations become more efficient. So you're getting to that lights out vision, because that's what it was called early on, lights out. It wasn't with AI necessarily, because a lot of the thought that went into that didn't have these capabilities we have now. So I think you're impairing yourself if you don't have the vision of being able to optimize in a way that it is almost using your imagination, because it's how far we can really push it at this point in time with the adaptation in geospatial science. And that's really what we plan to do, is adapt it into geospatial science with robotics control. Now that's an evolutionary step, and it's going to take some steps to get there, and we're going to have micro steps in that process. But that's where we really see that we can make a big dividend return on investment. So it becomes a macroeconomics and a microeconomics, because we can scale these micro advantages that we can deploy, such as robotics that has these physical AI capabilities, into a microcosm of AI perspective. With, like I said before, a Genesis thing that is enabling us to have a lights out operation. Because the only thing stopping us is our imagination at this point in time, because we're fast forwarding the ability to get complex tasks done very quickly and economically. Now, what value do you put on that? And then any CEO or managing director would say it's infinite. How much more process optimization can you give me? And it will be like Star Trek, where he goes, Scotty, give me more, to the blaster. Like, you'll literally be able to turn up the system,
and I think,
to a higher grade evaluation.
what do you think of? I mean, talking about Star Trek here. What do you think of space? Is that a new frontier that physical AI is going to open up?
So
You've had some
absolutely.
experience with space.
Yeah.
Can you give your
So
thoughts on it?
I've done some stuff. I've done some stuff there, and I love cosmology. Don't get me wrong, but I think this is going to enable, like, this advantage is key, because you don't have boots on the ground. If you can do process and mineralization optimization, and get mineral strategies together where you can deploy on site on another planet, you can start harvesting that planet's commodities and resources instead of using your own. So we can do outer space mining or moon mining, for example. Helium-3 is one of the biggest elements on the moon, and it can be used for power and production energy here on Earth, and it's more abundant there than it is here. So the moon mining is not a new concept, but it can be executed with physical AI, and that's
Its
where this
execution
can
is a
go.
tough bit, right? So when you don't need a lot of human interfaces, it drastically
Exactly.
shrinks the infrastructure you need.
Yeah, and that's what the whole point is: getting it right here first, get a lights out operation, reduce the infrastructure requirements, deploy or redeploy in outer space operations. I mean, that's the
Of
future.
the ocean, the middle of the ocean, in the deepest, ocean, the the furthest away
Absolutely.
deserts. So I think I love how Australia is kind of like we've got it all. We've got a version of Mars right here.
Australia has everything, and we just need the right guidance in, I suppose, government to really
Capital,
open up those.
and of course the right capital, and the right
Absolutely.
capital
And
up.
so deploying a capital in Australia, you got to think about it. We're resource rich. We're economically stable. We're very remote, so it creates more stability in that sense as well. So there's less fiscal risk to your capital. So if you look at it, it's a place beckoning for investment. So, and especially if we open up some of our assets, which we have a lot of assets in classes that are deemed not, I suppose, that people didn't want to open them up at one stage. But I think now, with the change in the world economy, people are going to see the need to change their mind around that.
No, that's perfect. Well, I think that's all we have time for this episode. Tune in again for next time. We are going to deep dive into rare earths, and I'd love for you to explain to the audience about where the status quo is, where the market is on rare earths, what we need and what we need to do, what we need to invest in. But till then, stay safe, everyone. And thanks for tuning in. And Nathan, thanks again for coming on. It was great to have you.
Thanks for having me, Tito.
Take care. See you.